This is how to draw the Lewis structure of phosphorus trifluoride, which is 1 phosphorus and 3 fluorine atoms. Now, many of you are used to the idea that you might take a phosphorus, which is in group 5 and therefore has 5 valence electrons, and 3 fluorines, which is in group 7 and therefore has 7 dots around it for 7 valence electrons, and try to draw a compound just by matching up dots. There's a way to do this with math that's helpful for more complex compounds. Here's how you would do this with the math. First, you'd calculate something called electrons required. And that would be the number of atoms in the molecule that are not hydrogen, which in this case is 4, times the number of electrons we need to octet those atoms, which would be 8, and we'd come up with 32. Then you could calculate something known as valence electrons. Valence electrons would be the 5 that phosphorus brings in, plus 7 times 3, because there are 3 fluorines with 7 electrons, that the fluorines bring in. Doing the math, that turns out to be 26. If we take 32 and subtract 26, we'll wind up with 6 electrons, which divided by 2 tells us that we will have 3 shared pairs. Okay? Another word for shared pairs is, of course, bonds. Okay? Now, we can also think about how we'd spend our 26 valence electrons in lone pairs. If we only have 26 electrons to work with, and we know that 6 of them are involved in shared pairs, that leaves us 20 divided by 2 left to become 10 lone pairs. Okay? Alright, now, the rules say that we start by putting the phosphorus in the middle. Okay, the first atom, which is phosphorus, is generally the central atom. And then we put the fluorines around it. Okay. Now, the rules say that we can have 3 shared pairs, so I will start with 1 bond to each of these. Remember that these bonds actually represent 2 electrons shared between phosphorus and fluorine. Okay? Now, since atoms like to have an octet of electrons around them, we need to do something about this. If you notice right now, this fluorine has 2 electrons by it. It needs 6 more to have 8. So I'm just going to draw 6 more electrons around it. There we go. Alright. And the other fluorine is just like it. It needs 6 more. And this fluorine is just like it as well. It needs 6 more. Now, if we focus on the phosphorus, notice it has 1, 2, 3, 4, 5, 6 electrons around it. That means it needs 2 more. Okay? Now, if I draw circles around the electrons around each atom, including the shared ones, you'll notice that everybody has an octet. This fluorine thinks it has 8 electrons around it. And so does this fluorine. And so does this fluorine. What about this phosphorus? Well, remember that the shared pairs we can consider belonging equally to both atoms. So, if I draw that last circle, how many electrons do you see around the phosphorus? 1, 2, 3, 4, 5, 6, 7, 8. Everybody's got 8 electrons. How many valence electrons did we use? We were supposed to use 26 electrons altogether. Did we? Let's check. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Yes, We used 26 electrons with 3 bonds to make this look like everybody had an octet.